Good day. We discuss the past year of STPM Term 1 in 2023, question 18, which is about the kinematics of the object. An object is released from rest in mid-A. Explain the effect of air resistance on the motion of the object. So this question gives you 7 marks. So you need to give as many information as you can. So the key information, I guess, is about the terminal velocity. So I'm not sure how is the marking scheme, but this is my sample answer. So we talk about when the object is falling through the A, it pushes against the air in its path. So this is where we introduce how we have the air resistance. The pushing creates an opposing force called air resistance, which pushes back on the object. So you can imagine that when object is falling, there are two forces acted on the object. One is the gravity pull, which is in downward directions, and one is the upward direction, which is the air resistance. So initially, as an object falls, gravitational force is greater than the force of air resistance, causing the object to accelerate. In theoretical, that when object is falling in vacuum, it is 9.81 meter per second square, but with the air resistance, it will be less than 9.81. So as the object speeds out, air resistance increases until it balances out gravity. So this is where we have the terminal velocity that the object stops accelerating and reaches a constant speed. So I'm not sure if it could get the maximum marks, but if you have other ideas as well, you can put it in the comment section below. So we shall look at the next question. A drone on a live sport event is flying horizontally at a speed of 30 meters per second, accidentally dropped a camera at the height of 120 meters. Neglect the air resistance. So determine the time taken for the camera to reach the ground. So it is quite straightforward. We have the height 120 meter and also the gravitational acceleration 9.81 meter per second square. So using the formula of S equal to ut plus half at square, where the initial vertical velocity is 0. So put in the values, so you should get the time is equal to 4.95 seconds. So the next question is about the horizontal distance of the camera before the camera lands on the ground. So in horizontal components, we have constant speed. So we only have one formula, which is V equal to S over T, or S is equal to VT. So put in the values of time obtained in question 1. So we have 30 multiplied 4.95, and you will get 148.5 meters. So the last question is to obtain the magnitude of the velocity of the camera just before the camera lands on the ground. So you should have done a lot of exercise of the similar questions. The velocity of the camera consists of the horizontal and the vertical component. Horizontal speed shall stay constant at 30 meters per second, and you will need to calculate the vertical velocity before you get the magnitude. So vertical velocity, just apply the formula of V equal to U plus AT. So the initial vertical velocity is also 0, as what we have done in question 1. So put in the values and you would get the vertical velocity is 48.6 meters per second. And after this, you just apply the Pythagoras theorem that we have the square root of the square of both in horizontal and vertical velocity. You will get the final velocity is equal to 57.1 meters per second. So that's all for this question. Thank you.